Introduce a new toy that I got. If you've been following along with some of my videos I've been making on using GPS with DonkeyCar, then you'll know that I built a DonkeyCar and I used this, actually it was this one, I used this SparkFun RTK GPS board to get high resolution GPS, and then modified DonkeyCar so I can record milestones and follow the milestones, and then I use that to race. So this is a great board and worked well, and it's based on a Z F9P chipset. You can see here Z F9P chipset, and it's great because it will talk to a lot of satellites, and it will accept another stream of information called the corrections. And then you can get 1 or 2 centimeter accuracies if you get good corrections. Now the issue I have with this board is simply that it's $275, and then you need, in order to take advantage of the full resolution of this board, you want a multi-band antenna, an L1, L2 antenna. They might have one linked down here. Yeah, here it is here. So an L1, L2 antenna, and you can see that's another 75 bucks. And this is the UBlox antenna. UBlox makes the chipset, so that's a decent antenna. And then you also need, for all of them, you also need one of these ground plates, and that's like 7 bucks. But the big costs are the antenna and the board itself. So you're talking like 350 bucks for the board and the antenna. So that's pretty expensive. And honestly, it's double that if you want to set up your own base station and send corrections from your own base station. In this article, I talk about how you can actually use your phone to get those corrections potentially, so you can save that extra one. But if you need that second base station, now you're talking $700. Okay, so here's the new toy I got. So I looked at alternatives, and I found this one from a company called Arju Simple, and this one is the exact same chipset. So it's the Z F9P chipset. You can see it there, and in fact I can roll over that. Now you can see Z F9P chipset. Let's open this image in a new window. There. So you can see ZF9P chipset. But if you look at this, it's $232. And that's better than $275. But it's way better than $275 because this includes the antenna, that very antenna that we were looking at before, that one that was like 73 bucks. So this is $232 for the board and the antenna. So instead of $350, we're talking $230 something. So, and it should work in the same way because it's using the exact same chipset. And that's one of the things I want to talk about today, is sort of look at the board and set it up and see if I can set it up in the same way I set up the SparkFun board. So here's the board again. And there's a few things to look at on the board. We'll start with the connectors and we'll go clockwise around. So this connector here is a micro USB connector. The SparkFun board has a USB-C connector, but frankly it doesn't make any difference because this will deliver enough power to power the board, and it's more than fast enough to deliver the necessary baud rates to get data in and out of it. So micro USB is not an issue here. So you can see this is power and GPS. So this is the one where we'll plug in the USB cable and then plug it into our Raspberry Pi, and that's how we'll get it power and how we'll get one of our serial ports. So moving on to the left, we see this other port here called Power plus Pixhawk. If you looked at the video where I showed the autonomous race that we did outside, one of the participants used a Pixhawk flight controller and Arju Rover open source software. So the Pixhawk flight controller is a well-known open source hardware project for flight controllers for originally for aerial rovers, but you can pair it with the RG Rover software and use it for ground-based vehicles too. It's a very powerful piece of software and a very powerful piece of hardware. And it will use GPS to do the same thing that I did with DonkeyCar, which is record waypoints and follow them. And so this is the port. This is the kind of port that the Pixhawk uses to get GPS in. So you can use this with your Pixhawk. With that, that's pretty cool. Now the next thing next to this is the SMA connector for an external antenna, and I got the SMA board. The SparkFun has the same connector. And then moving on here, on this side of the board, we can see RX1, TX1, and RX2, TX2. So the RX is the receive channel for serial port, and TX is the transmit channel for serial port. So they've exposed two more serial ports on the pins on this side of the board. And we actually need... I'll link the other video, but it talks about the need for two serial ports if we're using RTK, because we use one serial port to send the corrections to the board, and we need another serial port to read the positions from the board, the NMEA sentences from the board. And so when I use this board, I'll do what I did with the SparkFun board, and I'll solder some headers on here. Now you actually can buy a version of this that has the headers already soldered on, and they're pass-through headers. So they're female headers and they're pass-through headers, because this is designed to also work as a sort of daughter card on top of a Arduino Uno. So you can see this is Arduino Uno shaped, and these pins are organized like an Arduino Uno. So if you get one of these with the pass-through headers, you're going to have pins sticking out the bottom, very long pins sticking out the bottom, because it's expected that you're plugging this into an Arduino. But you don't have to do that. You can cut all those pins off and just use the female headers if you want, that are on top of the board, if you're averse to melting metal for fun. Okay, so there's a couple of serial ports. And then let's talk about these headers, and they go with this port here. And if you can see, this thing is marked power plus XB. And XB is a specification for these headers and a way to connect a radio that has pins on the bottom of it. So let me open up. I don't have an XB. Let me do here. I know Adafruit had an XB radio, and so I wanted to go look at that. And okay, yeah. So here's an example of an XB radio. So you can see these pins down here, and this would be considered a short distance radio, and if you look at how to connect it, then you just plug it in here basically, and then you could plug in USB serial here when you want to configure this board. When you want to configure the radio, and the radio uses just text commands, sort of basically like old modems used to, in order to set the baud rate, to set whether it's going to be in broadcast mode or receive mode, whether it's going to be receiver or sender, or whether it's going to be in broadcast mode. And so this one's considered relatively short range radio, and it will be anywhere from 40 meters to 120 meters range. So you would want one of these if you were going to set up your... The reason that you use one of these radios, right, is remember we have to get corrections into the ZF9P. And the way I'm doing is I'm sending it through the transmit pins. But another way to do it is to send it over radio. So if you were to send it over radio and you had one XB radio broadcasting the corrections, then you'd mount another XB radio on your GPS, and it would receive the corrections, and that's how the corrections would get into the the GPS receiver. And this is really handy. This is a really handy configuration. You can see that the SparkFun board does not have this, right? So I can't. I could use an XB radio, but I'd have to solder pins and connect it to one of the external. I'd have to do a bunch of stuff to get a radio to talk to this thing, but because these XB radios have this standardization and this uses that, it's much easier to add radios to these. So if you were, I think that's a big advantage. Now, I haven't tested it, I haven't used it, but it certainly seems like a big advantage to be able to just plug in a radio, plug in a USB connection to configure that radio and have that all working. That seems like it's way easier if you're going to use a radio than the SparkFun solution. So I think that's probably an advantage. Okay, so that's sort of all our connections. And let's look at some of the LEDs. I have some, when I show this board on video and the LEDs light up, sometimes it's really hard to see the individual LEDs, so it's worth going over them here. When you plug in the USB here, then you're going to be powering the board. I think when you plug it in here, you're only powering in the XB radio, and it's only for the purposes of configuring it. But here, when you plug in here, you're powering the whole board, and so this LED comes on. It's bright blue. So let's look at these other LEDs. When this has to do with RTK, so these two on this side matter to us more than anything else. So when you don't have any RTK at all, then this is actually lit. It's sort of like inverse. You'd think they'd light up a thing when you got RTK, but no, they light this thing up when you don't have RTK. And it's similar on the SparkFun board. There's LEDs over here on the SparkFun board, and they work in the same way. In that the LED is on until you get an RTK fix, and then it goes out. And then and when you're in float mode, so you progress to fixed mode. So you start out in non-RTK mode, and when you start delivering RTK corrections to the board, then this no RTK will start to blink. And that's, or it might be this GPS fix. No, this RTK one starts to blink, and that's an indication that it's gone into float mode. And then when it's extinguished, when it goes out, that means you're in fixed mode. And fixed mode is that high precision mode where you're like 1 or 2 centimeters. This GPS fixed button is not a button, LED is it initially, when you turn on the board, it's not on, and then it starts to blink. Actually, that might indicate that you're moving towards fixed mode, and then this extinguish means you're going towards RTK mode. Should, I guess, RTFM to figure that exact thing out. And these LEDs have to do with XB. When it's, I believe, when this chip is talking to the XB, that lights up, and when the XB is talking to this chip, that lights up. So I'm not going to be using XB radio for this, so I can ignore those LEDs. I only care about these RTK ones and the LED power ones. So that's a quick tour of the board. Now I want to show you how to set it up, and it's sort of exactly the same as how you set up the SparkFun board. So if you have the SparkFun board, this will also be interesting to you. So here's the board, and so here's the USB connector, right? So I haven't plugged this yet into my Macintosh yet, but I will, and then it will power the board. And here I've connected the SMA connector to the antenna, and I have the cord, which is a very long cord, more than you need when you're actually using this on your car, but I sort of need it now because I've got this stretched all the way over to a tripod near a window, so the antenna has some view of the sky. I don't think it has enough view of the sky for us to get into fixed mode, but we'll be able to get a GPS position from it. So now I'm going to plug in the board, and we can see these LEDs light up. And once again, the LEDs are here, right? And there's the let's switch back to here. Remember that so the board is, turned 90 degrees in here. So it'll be the ones aligned with XP and GPS fix. It'll be these ones over here. So yeah, so these ones are the ones we care about. These two. There's one here and there's one here, and they light up pretty bright, so we might not be able to distinguish them. We'll be able to tell when they blink and stuff like that. But so these are the LEDs we care about, and here's the power LED. So let's plug in the board to a USB port. If I can find the other end of the cable. Oh, here it is. Okay, plugging in now. Okay. So there we are. So now we have some lights. So that's the GPS fixed light is out, and the no RTK light is on because we don't have RTK, and the power light's on. So I have two LEDs on and everything else is off. All right, so then let's go over to, now we want to configure it, right? Now we want to test it and configure it. So we're going to run uCenter. I have a whole separate video on how to run uCenter on the Macintosh, and I'll link to that video. And I'll also say, if you can run it on Windows, run it on Windows, because uCenter is native Windows software. And to get it to run on Macintosh, you install an emulation program and you run it in emulation, and there's definitely some oddities with it. But I think you can get it to work. And the reason I'm doing it on the Mac now is because I couldn't video the software either. The software wouldn't video correctly on Windows because it's such an old piece of software, and the way the Xbox screen capture works didn't work correctly. But in any case, I'm showing it to you on Mac because I can record it better. But so now we're plugged in, and you can see some data flowing through here now, and you can start to see we're connecting to some satellites. And the American flag means it's an American GPS satellite. And that's all. That looks like all we've got so far. Let me see here. So when you first plug this in, you might not have any connectivity, and what you have to do is go over to the menus and click on the receiver menu, and then the connection menu, and then pick the COM port that your board is plugged into. And generally, certainly on Windows, it usually does a pretty good job of sniffing out which one it is, and it offers you that one. And then you probably want to set the baud rate up to, it'll start at like 9600. You want it to be like 115200. So it's a faster baud rate. So do those two things initially. Do connect to the correct COM port and set your baud rate. And then you can see that we're connected because you can look down here on the status bar at the very bottom of the window, and you can see that's green, COM1 115200. And it actually shows how many bytes per second that we're getting there too. That's kind of cool. Okay, so now if we look up here, we've got some more satellites. So here's a Russian flag. So this is the Russian GLONASS system. And then here's a Chinese flag, and that's the Chinese baud system. And this one without a flag at all, called EGNOS, that is actually it's a European one, and it's a European. I think it's a European Space Agency runs it. Europe actually has two systems. Their Galileo system is also another system that's used for civilian stuff. And you should usually start to see some Galileo satellites on here too. So I can typically see like 5 different sets of satellites with this UBlox F9 series board. So we can start to see we've got data, it's got a position, and I want to show you how to set up to get RTK data fixes in and get a better fix. This isn't how you do it when you're on the Raspberry Pi on your rover. This is just to test that your RTK's, your Ntrip server account and settings are working correctly, and that your receiver actually works correctly when it gets RTK corrections. So one thing to note here is in the fixed mode that we have is 3D fixed mode. It starts out as 2D, and then that fixed mode, when it's in 2D mode, when you first start up, this fixed mode LED, which is blinking now, is off totally. It's moved to 3D mode, and then that LED started blinking. So it's got more satellites now. It's got a better estimate of our position, including, I believe 3D means including, it understands what our altitude is. And then as it gets more and more data, then it will go into this thing called 3D/DGNSS mode. And then you're having better accuracy. And once we start delivering RTK corrections to it, RTCM, then it will go into a mode called float mode. And then finally, when it has applied lots of corrections, it'll go into this thing called fixed mode, and that's our highest precision mode. So to set those things up, you want to talk to your Ntrip server. So open up the Ntrip client dialog, and then you're going to fill out the caster settings, right? So when you signed up for your account with whatever Ntrip server provider that you used, right? I'm using a organization called UNAVCO, and I signed up online on their site, and then they sent me an email with the information I needed to talk to their servers. So they sent me the address. So this is the address of the UNAVCO servers, rtgpsout.unavco.org. I'm going to be receiving RTCM format corrections, and those are delivered on port 2101. And then they gave me an account with a password, and so I'm using that. And then once you enter all the correct information there, if this is the first time you've used it, you can do this thing where you hit this button called Update Source Table, and you can see now it's actually talking to the servers, and it's getting all the base stations that are provided by that server, in this case UNAVCO, and then you can pick from them. So you're going to want to go on whatever your provider site is and find out what's the one that's close to you, and then pick it from this list. And I happen to know that mine is called P200. And there it is. So I'll select that. And now I can just hit OK. And what will happen is, let's look down here. See this Ntrip client not connected? It'll connect. And then it'll start delivering. Then we'll be talking to the Ntrip server and it'll start delivering corrections to us. So I hit OK. And you can see, yes, it's connected. Just hover over that and see if it starts to tell us how much it's sending, like it did on the other one. It doesn't seem to be doing that. But already, look, see, we've improved our fixed mode to DGNSS fixed mode. And I did this once before. I think we can get to, and let's look at the board actually. And the board are no RTK LED, the one below the blinking one. That's still lit solid, so we don't have RTK yet. As we talk to the Ntrip server, we should get more corrections, and they should be applied to more satellites, and we should progress into a float mode, in which case that LED should start blinking, and then finally to a fixed mode, in which case that LED goes out totally. Okay, so now we know. Here's more Russian satellites and etc. Okay, so now we want to set up the board. So now we know that we can talk to the board, and the board can receive RTK corrections. Now our account works. Now we also want to set up the board so that it's appropriate for our use case, which is racing, right? So when we race, we want a couple of things. We want to be able to get updates really fast. So we want to get position updates as fast as possible. And to do that, we need to make sure we have a high enough baud rate on the various serial ports that we're using. And so we're going to show you how to set all that stuff up. And the other thing is that when we're using RTK, the actual precision of that position that we get, the latitude, longitude positions that we get in the NMEA sentences, is very high. When NMEA was first created, there was no such thing as RTK. So I think they use like 4 decimal places by default in NMEA sentences. But we can do much better than that. And so we can turn on a mode where we use high precision mode NMEA sentences. And then it'll include more decimal places in our latitude and longitude positions. Okay, so let's show how to do that. First, let's show how to set up the baud rate for the serial ports. To do that, we go into the View menu, and then we open Configuration View. And I'm going to move this to the center of the screen. And then we're interested in changing the baud rate of a port, and so we're going to go to Ports. So in this list on the left, click PRT Ports. And you can see over here, now it's going to show us the various ports, and we can select ports from here. So I'm going to set up UART1. That's already set up there. And you can also see we could do things like change the protocol in is what kind of data it expects to be listening for on the serial port, and what kind of data it's going to output on the serial port. And depending on how you're using it, you can crank those down so that you're not listening for things that you don't care about, and you're not outputting things you don't care about. And that way you will use your serial port and your chip's resources more efficiently. But we can see the baud rate of the board by default is 38400. So we want it to be 115200. So we're going to pick that from the baud rate list. Now we've selected this in the software, but it's not in the board yet. So what you have to do is send the command to the board to set the baud rate. And you do that by hitting the send button here. And now it's set that baud rate. Now it's set the baud rate in the board's working memory. But if we were to turn off this board, unplug it, and then plug it back in, it would default back to 115200. So what we need to do is, many boards have a way to remember this information, so the next time they start up, they just use the saved configuration. Some boards use battery backup RAM, so as long as the battery's good, it'll remember it in RAM. And this board uses flash memory, so you can actually write it to flash storage, and then it will read it from flash storage when it first starts up again. And so the way that you do that, if I was to close this, it will offer me a way to do it. Or we could just go there. So what it's going to do is going to bring us to this configuration, the third one down. So let's do it just so you see what this is. You have made modifications to the GNSS receiver, but you haven't saved the settings. Would you like to switch to the save message? Yes, I would. Okay, so now it's switched us automatically over to this CFG configuration thing, and you can see, and it's also selected save current configuration as the operation that's going to send, and it's pre-selected battery backed up RAM and flash as the things that it's going to tell the board to update. So now when we hit send, it's going to send a command that says save your current configuration into permanent storage, so you can use it the next time you start up. So I'm going to hit send. So I just did that. So now this is now stored on the board, and when I start up the board the next time, it will remember the baud rate setting. Okay, so now we've configured the baud rate for our serial port. Now we want to set how often we get position estimates. Basically, you can balance how often you get them versus how good the estimate is. And the reason that that's a balance is that the chip has only a certain amount of resources. And if you're asking for positions very, very quickly, then it can't use the estimates from many satellites. It can't talk to that many satellites and coordinate all their information and get you a position estimate that fast. So what it starts to do is it starts to first drop out a satellite system. So like I said, I can commonly talk to 5. If I crank up how often I want an NMEA sentence, it'll start to drop out some of those satellite systems. And so it's talking to less satellites. If it talks to less satellites, then the accuracy goes down, but the rate goes up. So you're going to have to balance based on your chipset and your use case. For us, 10 hertz is good. Anything over 10 hertz is good. Okay, so now we want to set the rate at which we update. So we're going to click on the rate configuration here in the configuration view. And this is the default. So you can see the default, it's set to a measurement period of 1,000 milliseconds or a second. So that's just one request per second. So I want it to be 10. So I'm going to change this to be 100 milliseconds, and you can see that it's calculated. It's going to be 10 hertz. So now I'm going to send that to the board. So now the board is starting to deliver position estimates 10 times a second. But now I have to also, if I want it to do that the next time I start up the board, remember I have to save it to permanent storage. So I go to the configuration thing and make sure I save current configuration, and then I send that command so it saves the current configuration. Okay, good. So now we've updated the baud rate of the serial port. We've updated how often we get a position estimate. Now we want those position estimates to be high precision if we have an RTK board. If your board is not RTK, you don't have to do this part because it will deliver the precision that NMEA allows by default. Okay, so we want to change NMEA precision. So we click on the NMEA configuration. Okay, so normally this would be available to me on the Macintosh. It doesn't seem to become available on Windows. It does, but if you have an RTK board, this should be available to you, and you just click it, and then you're going to hit send, and then you're going to do that thing with configuration and hit send again, so it gets put into permanent memory. But it's this high precision mode that you want checked on in order to use. In order to get more decimal places in your position estimates. So if you do all that, then I think you're ready to use your GPS board with DonkeyCar. So that's that. Thank you for listening, and I'll link to the other videos in the article that has details on this in the video.